Hi guys, welcome back to Tech Engineer. I am Shiva. Today we are going to discuss about combined technical service exam for electrical engineers, right? So today we are going to discuss to explore the electrical circuit. Let's see one by one. So these are our content we are going to discuss in this video. The first one, introduction to electrical circuit, component of electrical circuit, type of electrical circuit, series and parallel connection, Ohm's law in electrical circuit, circuit analysis techniques, applications of electrical circuits, and safety measure in electrical circuits. So we have a 8 slide. Let's see one by one. The first one, introduction to electrical circuit. The definition of electrical circuit is an electrical circuit is a closed loop through which an electric current can flow, right? It has closed loop, right? The second one, basic function of electrical circuit. The electrical circuits are designed to provide a path for the flow of electricity to power various devices. What is the function? To provide a path for the flow of electricity to power various devices, right? Key component of electrical circuit. The electrical circuit consists of components such as resistor, capacitors and inductors and power source like batteries or generator. These are all key components we are using in the electrical circuit. The fourth one, flow of electricity in electrical circuit. In a circuit, electron flow from the negative terminal of the power source to positive terminal. Flow of electricity is what? Negative terminal of the power source to the positive terminals, right? So let's see number 5, conductor and insulators of electrical circuit. Conductor allow the flow of electricity while insulators prevent or limit the flow of electricity. This is our very important points. Please note it. Let's move on another slide. So in this slide we are going to discuss about components of an electrical circuit. What are the components we are using? Number 1, voltage source. Number 2, resistors. Number 3, capacitors. Number 4, inductors. Number 5, switches. Let's see what is voltage source. Provide a electrical energy needed to drive the current in a circuit, right? It is called voltage source. Provide the electrical energy needed to drive the current in the circuit, right? So what is resistance? A component that resists the flow of electrical current, often used to control amount of current in a circuit. So why we are using resistors? The component that resists the flow of electrical current, right? The next one, capacitors. Why we are using capacitors in electrical circuit? Store electrical energy in an electric field, commonly used for filtering and energy storage in the circuit, right? Yes. Move on another one, inductor. Why we are using inductors in the electrical circuit? Let's see. Store energy in magnetic field. When current flow through it, often used filters and energy storage applications. So move on, fifth one, switch. Why we are using switch in electrical circuit? Control the flow of current in a circuit, allowing for the circuit to be turned on or off, right? So move on, next slide. It is very interesting topic. Type of electrical circuits. Actually, we have a five types. One is closed circuit, another one is open circuit, another one is short circuit, and fourth one complex circuit, and fifth one combination circuits. So let's see closed circuits. Number one, a closed circuit is a complete loop where current can flow continuously without interruption. Here, there is no interruption involved, right? The example, light bulb connected in a closed loop with a battery. So here, this is one lamp connected with a battery, right? This is called closed circuit. So move on, second one, open circuit. What is open circuit? An open circuit is a broken or incomplete path where current cannot flow. Now we are connected bulb here, we are connected battery here. Can the current is flow? No, this is wrong, right? So this called open circuit, right? For example, switch in the opposition, preventing current flow, right? In our home, when you are switch off the switch, the bulb cannot be glowing, right? Because of that, there is no current flow, right? So move on, third point, short circuit in electrical circuit. A circuit occurs when a low resistance path is created between 2 points in a circuit, can lead to excessive current flow and potential damage to the component. For example, accidental connection of the positive and negative terminal directly, right? So this is short circuit. Here positive line, here negative line. Now someone is connected here. This is called short circuit, right? So move on, fourth point, complex circuits in the electrical circuit. A complex circuit consists of interconnected component and multiple paths for current flow. Require careful analysis and understanding of each component role. For example, circuit board in a electronic device like smartphone, right? This is all complex circuits. Move on, fifth point, combination circuit in the electrical circuit. A combination circuit is a mix of series and parallel connection within same circuit. Offer flexibility in designing circuit to meet specific requirement. For example, household electrical wiring combination, its series and parallel connection, right? Move on, next slide. In this slide, we are discussing about series and parallel connection. So we have two connections. One is series connection, another one is parallel connection. In a series connection, components are connected end to end, creating single path for current flow. For example, we are connected one lamp here, one battery here. This is series connection, right? So the series connection When we are using multiple component, we added the R total value. For example, here is 10 ohm resistors, here is 10 ohm resistors. The total 20 ohm resistors connected here for this example. So we are here given 10 ohm, 20 ohm, 30 ohm. So when it is series circuit, you added all the thing, you get 60 ohm is the answer, right? So in case in a parallel connection, components are connected across each other, providing multiple path for current flow. For example, here one resistor is connected, here is one resistor is connected, here is one resistor is connected. It is called parallel connection, right? In parallel circuit, the total resistance value is what? 1 by R1 plus 1 by R2 plus 1 by R3. You added all the ohms value, you get total resistance value, right? So the major key difference between the series connection and parallel connection, in a series circuit, the total resistance increase with each additional component, right? The total resistance increase with each additional component, while in parallel circuit, the total resistance was decreased, right? This is important key points. So move on the next slide. So in this slide, we are discussing about what kind of law occur in electrical circuit. See Ohm's law here, right? So what is Ohm's law? Is first point introduction to the Ohm's law and the mathematical expression of Ohm's law and the relationship and implications of the Ohm's law. The fourth point, application in a circuit design by using the Ohm's law. And fifth one, significant in electrical engineering. Let's see one by one. The first point, introduction to Ohm's law. Ohm's law is a fundamental principle for the electrical circuit, right? The related to voltage, related to current, related to resistance in a circuit, right? So here voltage represent V, right? And the current represent I, resistance represent R, right? The mathematical expression of the Ohm's law in the electrical circuit, Ohm's law, it's always denoted by V equal to I into R. The V is voltage, I is current in the amps, and R resistance in the ohm, right? The relationship and implications. The point one, current is directly proportional to the voltage, right? The second one, current is inversely proportional to the resistance. Predict behavior of electrical circuit, right? The fourth point, move on the fourth one, applications in circuit design. Help in designing and troubleshooting of the circuit. Determine the power dissipation in V in the I, right? Ensure efficient operations and prevent overloading as well as, right? Move on fifth point. Significant in electrical engineering, crucial for analyzing electrical circuit. Optimize circuit performance, prevent component overloading, right? So move on next slide. What kind of circuit analysis techniques involved in the electrical circuit? The first law involved Kirchhoff law. Second one, mesh analysis. Third one, node analysis. Fourth one, Thevenin's theorem. Fifth one, Norton theorem. So let's see one by one. What is Kirchhoff law? The Kirchhoff current law KCL state that the total current entering the junction is equal to total current leaving the junction. For example, 10 amperes come in this position. Here is the one point and it is move on the other side 10 times. Right? Yes. In Kirchhoff voltage law, it's called KVL, state that the total voltage around a closed loop in a circuit is equal to sum of voltage drop. Right? So move on the mesh analysis, a method used to analysis circuit by applying KVL to each mesh or loop in the circuit. It is help in determining the current flowing through the different branches of the circuit. For example, we have a 3 loop. We can easily find one by one, right? So move on node analysis. A method used to analysis circuit by applying KCL. Whenever you are going to analysis mesh, we can use KVL. Nodal analysis, we can use KCL, right? So move on the Thevenin's theorem. The Thevenin's theorem states that any linear electrical network can replace an equivalent circuit consisting of single voltage source and single resistance, right? And move on to the one Norton theorem. Linear electrical network can be replaced by an equivalent circuit consisting of a current source. Here is we are using voltage source. Here we are using the current source. And also single resistors connected between the series with the resistors. Here we are using parallel connection with the resistors. This one is very important points. So, move on next slide. This slide we are discussing about applications of electrical circuit. For we have a 5 type of usage by using the electrical circuit. The number 1, power distribution. Number 2, lighting systems. Number 3, electronics. Number 4, renewable energy systems. Number 5, medical equipments. So let's see one by one. The electrical circuits are widely used in power distribution system to transmit electricity from power plant to home or business or industries efficiently and safely. That's why we are using the electrical circuit. The lighting system. Electrical circuits are essential for powering lighting system in various settings, including the residential, commercial, and outdoor environment. Third point, electronics. Why we are using electrical circuit in electronics? Electrical circuits from the backbone of electronic devices such as smartphone, computers, televisions, and other consumer electronics. Right? Move on the fourth point, renewable energy system. Why we are using electrical circuit? The electrical circuit play a crucial role in renewable energy system like solar panel and wind turbine, converting natural resources into useful electricity. Move on fifth point. This is a very crucial point. Medical equipments. Why we are using electrical circuit? The electrical circuits are integral to operations of medical equipment such as MRI machines, X-ray devices, and life support system in healthcare facility. Right? So move on slide number 8. Safety measure in electrical circuit, right? What are the safety measures involved in the electrical circuit? This is important for in the field of electrical engineering, right? The first one, personal protective equipment (PPE), and second one, de-energizing circuit, avoid overloading circuit, proper grounding, prevent electrical hazard. Number one, always wear insulated gloves and safety goggles. Ensure PPE is appreciated for electrical work. If you are doing any electrical work, you need to follow the PPE first. And number two, de-energize circuit. Ensure circuit was de-energized before we are going to take maintenance, as well as use a voltage tester to confirm either the flow of electricity or not, right? So third point, avoid overloading circuit. Do not exceed the maximum current rating. If you are using 30 ampere circuit breaker for your entire load, now you can connect 40 ampere external load. It will be create overload and creating fire hazard as well as, right? Follow specification for circuit components. And one more point is proper grounding is must. Properly grounded for all electrical circuits. Prevent the risk of electrical shock, right? So how to prevent the electrical shock? What kind of actions we need to take? Keep water, liquid away from circuit. Regularly inspect of wear, damage or overheated. Use a class C fire extinguisher for electrical fire, right? This is very important points we are discussed in this video. We will move on chapter wise video for upcoming classes. Thanks for watching Tech Engineer. Have a great day. Please subscribe our channel for getting more update and click the bell icon.